Hi all. We are going to use this video to demonstrate some homework problems. First of all, the graphs of different models. We have this linear model, this is the general format. Pn is the output, n is the input, d is called the growth rate. If it is positive, it means growth. If it is negative, it means decline or decay. And P0 is called initial value. So in terms of graph, since it's a linear model, actually graph will be a straight line. In other words, if you have a straight line, look like this or look like this. So as long as it is a straight line, it is a linear model. And if it's a straight line going up from left to the right, that only means it's growth. D will be positive number. And if the line going down from left to the right, it means it's declining and D is a negative number. So that's how you identify model types by looking at the graph. What is the graph of a exponential model? Exponential model looks like this. Output Pn, initial value P0, input is n. So this part is the same as in linear model. Difference that this part is a 1 plus growth rate R. If R is positive, it's growth. If R is negative, it's declining. What about the graphs? Two types of graph. In either case, it is a curve. For example, you could have something that look like this. So increasing from left to the right, and it's a curve. And it goes only one direction, keep increasing from left to the right. Or you have curve, smooth curve, and keep decreasing from left to the right. Either way is an exponential model. This one corresponding to R being positive, so it's growth, you're getting higher and higher the output. If the input getting bigger and bigger, the output higher. And this is decreasing of exponential model. When n gets bigger and bigger, the output Pn getting lower and lower. So this is the exponential model. This is corresponding to R smaller than 0. But either way, it only goes in one direction. Either it only goes up or only goes down. It won't make a turn. If it make turn, even though it's a smooth curve, it's not an exponential model. So this one just try to illustrate what is a graph that is neither linear or exponential, nor this is the spelling, neither linear nor exponential. So something like this, you have a curve, but this curve is not going in one direction. It's going down, then going up, change direction, or this way. No matter how many turns, as long as it's not a line, it's not linear. As long as you make a turn, it's not exponential. So that's just some clarification on the graphs of different models. Now, next topic is how to calculate the rate of change if you are given 2 points. So we have 2 points given, x1, y1, x2, y2. Basically, we just have 2 pairs of numbers. Now, according to the definition of slope, which is the same as rate of change, they're just different names for the same thing. So basically, the slope, usually we use m, lowercase m to represent that, equals y2 minus y1, x2 minus x1. Or m equals y1 minus y2, x1 minus x2. This will give you exact same slope. And this will give you exact same slope. There's no difference which one you use. Just make sure use y value minus y value divided by x value minus x value. The way you use these 2 pairs of numbers is that it has to be consistent. If you use y2 minus y1, you have to use x2 minus x1. If you use y1 minus y2, you have to use x1 minus x2. So the order of these 2 numbers have to be consistent. Now let's look at the example from the homework. Now, basically, I guess if you did this part of homework, this should be familiar to you. This is the point 1, the first point. This is like x, this is like y, just one pair of numbers. But in this case, the first number represents time, the second number represents the height. So basically, when we calculate the rate of change, the first number always represents input, second number always represents output. If you look at the rate of change, the definition, change in height divided by change in time. That means this is the time is input, and this height is output. Over the time, the height will change. But how do we do the calculation? This is like x1, y1. This is like x2, y2. So all we need is do some calculation. Let's do that. And so the first one, from point 2 to point 1, point 2 to point 1. Again, like I said before, it doesn't matter which one you take it as the first point, which one second point, as long as you use y minus y, x minus x in a consistent way. So I'm going to use 136 minus 97 divided by 0 minus 6. Let's do that. 136. Let's use the parentheses. Let's redo that. 136 minus 97 parentheses divided by 0 minus 6. 0 minus 6. This way, the calculator will do this part of calculation first, and this part of calculation, then do division. Oh, I'm supposed to use division between. Let's do that again. 136 minus 97, close parentheses, and divided by 0 minus 6. So everything is good. We got negative 6.5. So put it in here, read 1, negative 6.5. Now let's look at the read 2. From point 3 to point 2. Don't worry about from point 3 to point 2 or from point 2 to point 3 as long as you use same 2 points. So this time we're going to do 97 minus 71, y minus y over x minus x, 6 minus 10. So 97 minus 71. Minus 71 divided by 6 minus 10, 6 minus 10. So everything is right. So we got negative 6.5 again. Negative 6.5. Sure, you can continue to do that if you have more points. I only have this 3 points as demonstration. Now, how do we calculate read 2 to read 1 ratio? This is a ratio of reads. These two are reads, right? Rate of change, reads. So apparently they're the same. This is a read 2 to read 1. We use this number divided by this number. They happen to be the same. So get 1. So that's how you calculate the rate of change and the ratio of those rate of change. And each value has its meaning. First of all, if the rate of change and also called a slope is positive, then the graph is increasing from left to the right. By looking at the sign, you notice the graph is increasing or not. If this is smaller than 0, it's decreasing for sure. So if they ask you, is this increasing or decreasing? Your answer is decreasing from left to the right. Now, how do we tell if this from this rate of change and ratio, how to tell whether it is a linear model or exponential model? Without a graph, we can also tell. If this number, rate of change, if the rate of change, which is also called slope, that's important, is a constant. That means they don't change. like this one, negative 6.5, negative 6.5, negative 6.5, they're all the same. That's an indication of it is linear. It's a line. Again, if it's negative, it's decreasing, right? If it's negative and the same, that means it is a line going down from left to the right. Because a line can only have one slope, right? Because it never change, it goes in one direction. That's why if this rate of change is constant number, it's just a line. If it is positive, a line going up. If negative, a line going down. This is a line going down. Now let's see how do we tell if it is exponential. First, if the rate of change is increasing, rate of change is increasing. At least it's not a constant number. Okay, let's see. Let's do it this way. It's not constant. And the ratio is greater than 1. Then this is exponential. It is greater than 1 and constant. Has to be constant. The ratio has to be constant too. Then exponential. This is exponential. And increasing. And increasing. But if the rate of change is not constant, and the ratio is smaller than 1 and a constant, then it is also exponential. And decreasing. Now let's look at a example here. And you all have this part of homework where you calculate the rate of change, you calculate the ratio of rates, right? This is one of the results. Say, look at that. First, this rate are positive number, it means increasing from left to the right. But how does it increase? Is it increase like a line going up or like a curve going up? That's why if you need to look at if these numbers are constant or not. If it is constant, that's a straight line because rate of change represents slope. Slope never change. That's a straight line. In this case, this is a straight line. That's why this ratio is not greater than 1, it's not smaller than 1, because this rate never changes. That's why it's always 1. And that's the case of the case of a straight line going up. But if you have this rate negative, for example, negative 7.0, negative 7.0, negative 7.0, and this is still 1, 1.0, 1.0 never change, this is a line going down. Line decreasing. That's the case. Now, what if this is the rate that's not a constant, okay, not a constant, and currently I don't have number in my head, but it's not a constant. Let's write it this way, not a constant. So separate them, not constant, but this one is a constant, and greater than 1, you have exponential going up. And another situation, the last one is that this one is not constant. That means this rate slopes keep changing. And this one, you need to look at this ratio between rates. So this is also constant, but smaller than 1. It is going to be exponential and decreasing. So you have something look like this. And that's all for this video. Bye.